Hi, today we're going to learn about the depreciation of a car using linear functions. All right. So, did you know that on average, new cars depreciate 19% in the first year? 19%. That is outrageous. But luckily, it doesn't always continue on that pattern. There are two commonly used models for depreciation. There is straight line depreciation, the one we're going to focus on today. And then there's accelerated depreciation on the right. The accelerated depreciation is new cars, usually the first year or two. Then it becomes a straight line depreciation. So let's look at an example of the depreciation of a car. As you can see here, the sharpest dip in your car's value is in that first year. Then it tends to taper off a bit, looking much more like a linear line. So we can use linear models to model it and make some predictions about how much a car is going to be worth. Here are three examples. There's a Chevy Spark, an Audi, and a BMW, all having that same really sharp beginning and then gradually becoming more of a linear type of decline. All right, so since it is a linear type of decline, we can use linear equations to model it. And remember the one we use a lot, the slope-intercept form is used to model any linear lines. So we're going to use that to help us today. So to get the equation of the value of our car, we can substitute the variable I for our initial value. So here's our equation. That I represents the initial value. And notice that's also going to be our y-intercept, where the D is the annual depreciation, the amount the value declines each year, and that's going to be our slope. All right, so our slopes are going to be negative since it is declining in value. And annual depreciation can be found by taking the initial value minus the salvage value, or it could be the value 1 year when you first buy it and then maybe the value 5 years later. So you can use that as well. And we're going to use that on our assignment for lesson 6. But this is the generic equation. Initial value minus salvage value, which is the amount when it's done, when you no longer use the car, and divided by the useful life of the car. So let's look at an example. Sam bought a used car from his friend. The initial value was $2,200. The salvage value of the car, $100, and it's likely to be useful for 6 more years. All right, so we can use that to find our slope, or find that annual depreciation, the amount it's going to depreciate each year. So the initial value, $2,200, minus the salvage value, $100, that's how much it's worth in 6 years, divided by 6. So 2,100 divided by 6. And if you break out your calculator and do that, let me break out mine. $2,100 divided by 6 is 350. $350. Writing off to the side here. So that is the value of our car. That's how much value the car loses each year is $350. So that would be our slope if we were using it. It would be minus 350 if we were using that in our equation to do some modeling. All right, let's try another one here. Dana bought a used car at a dealership. The initial value, again, that would be our y-intercept, has an initial value of 5,700, a salvage value of 100, and it's useful for 8 more years. So let's calculate our annual depreciation. 5,700 minus 100 divided by 8. 5,600 divided by 8 is 700. So our car, Dana's car, loses $700 of value each year. And again, if we wanted to write that as an equation to model it, y equals our initial value was $5,700 minus our annual depreciation, 700, times x. So our car loses $700 per year, and it started at 5,700. All right. We can use this information to help us figure out how much it'll be worth in the future. So Dana's car, remember, loses $700 each year. So how much will it be worth in 3 years? Well, we put this into our equation. $5,700 minus 700 times 3. That would be 5,700, and 700 times 3, that's $2,100. So our car will be worth, 7 minus 1 is 6, 5 minus 2 is 3. Car will be worth $3,600. All right. And there again is the work. All right, take a moment. See if you can determine this answer. Pause the recording and then come back. All right, hopefully you paused the recording. Notice it has the annual depreciation calculated for you here. We already know it's going to depreciate $600 per year. So our equation, it's initially worth $4,300 minus, let's drop in $600 per year. That's our equation. If we want to know what it is worth after or in 1 year, it would be 4,300 minus 600 times 1. Or $3,700. That's how much it'll be worth after 1 year or 1 year. Hopefully that matched up with what you had. All right, so again, the straight line depreciation model generally applies to older cars, usually at least a year or two old. Once that car stops being relatively new, definitely goes down by the same amount. So here is an equation that is modeling a car. See what you can tell me about the car. Go ahead and pause the recording for a moment. Think about this equation. See what you know about the car just based on this. All right, hopefully you've thought about this for a little bit. And knowing this equation here, this is in slope-intercept form, similar to the ones we were doing just a minute ago. And as we talked about, that y-intercept represents the initial value. So the car was initially worth, whenever it was purchased, initial value $32,000. And the annual depreciation, we get that from the slope. We can see our slope here is negative 4,000. So the annual depreciation is $4,000. All right. So look at this one. See if you can come up with this one. What can you tell me about the depreciation of the car modeled by this function? Again, pause the recording. See if you can answer those questions. What is its initial value? And what is its depreciation, annual depreciation? All right. Hopefully you found that the initial value, 10,345. That's the initial value of the car. And its depreciation each year is $2,030. All right. So Susan bought a car for $5,600. The car will last another 8 years and its salvage value is $100. What is its annual depreciation? Again, this is the same as what we have been doing. $5,600 minus 100 divided by 8. Pull up my trusty calculator. Tells me that my annual depreciation, $687.50. All right, use this step. See if you can create the equation. What would be the equation that would model this car? Model Susan's car. Pause the recording if you need to. All right. Hopefully you found that the model for the car would be y equals 5,600 minus 687.50 times x. Or you could write it as negative 687.50x plus 5,600. Either way, same equation, still modeling that car. Plus 5,600. Either way, it is the same equation. All right. We just talked about that. So your homework, there is the straight line depreciation extra credit. So let me know if you have any questions, and I will see you guys later.